Assalamualaikum and very good day to all examiner. My name is Muhammad Nurhaziq bin Nordin. I am a final year student from Bachelor Degree in Applied Chemistry. Today, I would like to present my final year project entitled A Review on Effect of Chemical Refinements on Natural Fiber Composite Properties. My supervisor is Madam Salamia Zakaria. Firstly, I will present about background of study. Natural fiber composite are composite material produced by a matrix with a reinforcement of natural fiber. The matrix used in manufacturing of natural fiber composite is polymer matrix such as resin. The function of the matrix is to hold the natural fiber together inside the polymer matrix. Natural fiber composite have two major issues, which are the hydrophilic nature of the fiber and the hydrophobic nature of the matrix. Chemical treatment on reinforcing fiber may reduce its hydrophilic tendencies and improving matrix compatibility. Next is problem statement. Using natural fiber as fiber reinforced material, the addition between natural fiber and polymer matrix may create a problem in the dimensional stability of the composite, since there are different polarities exist between hydrophilic natural fiber and hydrophobic polymer matrix. The combination of hydrophilic natural fiber and hydrophobic polymer matrix might result in lower dimensional stability due to the weak interfacial addition in natural fiber polymer composite. Next part is significance of study. From this study, the researcher will get information about the effect of chemical refinement on natural fiber composite properties. The information obtained will guide them on fabrication of natural fiber composite in selection of the best chemical refinement method for the specific filler that to be used. The finding from this research also can be used to aid researchers in developing new natural fiber composite with improved performance. Chemical refinement on natural fiber method will improve the natural fiber composite in terms of interfacial addition between natural fiber and polymer matrix. Then it also can widen the usage of natural filler in composite development as well. For objective of this study, the main objective of this research is to study the effect of chemical refinements on natural fiber composite properties. This study suggests several research objectives to be achieved as follows. First, to determine the type of chemical refinement used on fiber refinement for natural fiber composite. And second, to determine the properties of natural fiber composite based on the effect of chemical refinement on natural fiber. Next, we move on to literature review. I will summarize all chemical refinement that being used in fiber refinement. From the finding in alkaline treatment, sodium hydroxide treatment reduced the hydrophilic character of the coil fiber, as demonstrated by the lower water absorption percentage of sodium hydroxide treated coil fiber composite. Sodium hydroxide solution entered the lignocellulosic structure in the coil fiber to efficiently remove hemicellulose. Then the sodium hydroxide treated coil fiber were less hydrophilic. The sodium hydroxide treated coil fiber went to epoxy resin more readily, resulting in greater mechanical interlocking between the coil fiber and the epoxy and minimize the void space around the fiber particle. Next chemical refinement method is silane treatment. From the finding, the silane treated polylactic acid short bamboo fiber composite was obtained highest mechanical properties in tensile strength and Young modulus. The silane treatment improved interfacial addition between the resin and the fiber, as well as the mechanical properties of the composite. The silane treated composite have the lowest water absorption rate and the weight loss rate. Improved interfacial addition between the polylactic acid matrix and bamboo fiber inhibited water penetration in silane treated composite. Next, we move on to acetylation treatment. From the finding, the tensile strength and modulus, also flexural strength of polypropylene acetylated banana bunch fiber composite increased due to the removal of lignin and extractable, slight increase in cellulose content, and had a little portion of hemicellulose converting to acetylated hemicellulose. The acetate group reaction reduced the hydroxy group on the fiber surface, making the fiber more hydrophobic. The hydroxy group on the fiber cell walls were modified to minimize moisture absorption, which was ascribed to improve matrix fiber interaction. Next part is benzylation treatment. From the finding, the removal of lignin and hemicellulose may have improved tensile strength by making it easier for the fibers to reorganize in the tensile direction and causing higher tensile strength. The benzylation treatment removed contaminant from the surface of the fiber and improved the interface quality by interfering with the moisture absorption process. Due to the fibrillation effect, the treated fiber displayed a considerable improvement in interfacial shear strength value after benzylation treatment. Fibrillation increased the surface area available for interaction with the matrix material for penetration and bonding with the fiber cell, resulting in improved interfacial adhesion. Next is sodium citrate treatment. From the finding, the increase of tensile and fractal properties of treated composite may be explained by the fact that a stronger fiber matrix adhesion results in more stringent limitation on relative displacement between fiber and matrix, especially in the linear elastic phase. The mechanical property increase might be addressed to the decreased void content inside the laminates in addition to the stronger fiber matrix adhesion because of the sodium citrate treatment. Chemical components such as lignin, hemicellulose, wax, and oils might be removed from the fiber surface using sodium citrate treatment. From the finding on stearic acid treatment, the tensile strength of the stearic acid treated empty fruit bunch fiber composite was increased. The presence of the carbonic group of stearic acid, which has able to create hydrogen bond with the hydrophilic group of the cellulose and hydrocarbon chain with the matrix of the polymer, which is hydrophobic group. When reinforced with treated fiber, polymer exhibit stiffer behavior and can allow more stress at the same strain level. This was due by a chemical reaction that improved the adherence of the fiber to the polymer matrix. Treatment with stearic acid increased the interfacial adhesion of the fiber to the polymer matrix, resulting in composites that were stronger and more rigid. Last part in chemical refinement is sodium bicarbonate treatment. From the finding, the tensile strength of scissor fiber rise with sodium bicarbonate treatment. The establishment of strong hydrogen bond between cellulose fibrils caused partial elimination of hemicellulose, resulting in compact packing in cellulose fibrils. Fiber fibrillation begins after sodium bicarbonate treatment because non-cellulosic components such as hemicellulose and wax are partially removed from the surface of fiber, which results in a smoother and cleaner surface. Due to the partial elimination of hemicellulose and lignin, sodium bicarbonate treated scissor fiber has a decreased water absorption. In conclusion, the chemical refinement of natural fiber can improve the mechanical properties of natural fiber composite. The chemical refinement of the fiber may not only change the fiber surface, but also improve the fiber strength to increase adhesion between the fiber surface and the polymer matrix, which the water absorption of composite will reduce and their mechanical properties will improve. Alkaline treatment is the most technique used in chemical refinement of fiber refinement because of its effectiveness and its low cost compared to other treatments. Based on the chemical refinements that were included in this review, each treatment that applied on natural fiber will give different results on properties of natural fiber composite. For recommendation, it is recommended to do more research on fiber refinement in determining a new technique for the chemical refinement of natural fiber. Doing new research on fiber refinement will discovering a new technique for chemical refinement on natural fiber that can be used and applied it in the future. The researcher should do more research on isocyanate treatment, olechloride treatment, and titanate treatment to prove that all these treatments can be used to treat natural fiber, and this treatment will be used as chemical refinement technique for fiber refinement in the future.